Okay, hello everyone. So today's Monday, and we are going to talk about this working sheet, the charged particle between two plates, which is a sort of capacitor. Okay, so let's jump into the question straight away. Okay, a battery of unknown voltage connects to conducting plates a micro for a -5 microcoulomb charge of mass 2 gram requires 4 Newton force to hold it at rest as shown at right. Ignore gravitational force as they are very small compared to the electric force here. What is the battery voltage? Show your reasoning. Okay, so first let's draw the free body diagram because we ignore the gravity force, so we only have the horizontal forces left with. Okay, so because our hand is here, which means that the hands wants to stop the ball from moving to the left. Therefore, the hand should give this ball a force to the right, and this is, as it says, 4 Newton. Okay. So to balance this, then we expect the electric force pointing to the left and has the same magnitude of this force introduced by hand. Okay, so the electric force is 4 Newton. Okay, and recall that the electric force Fe equals to the electric field times Q. Okay, so that we have 4 Newton equals to E times Q, and Q is 5 times 10 to the -3, -3. Okay, and this means that E should be 0.800 newtons per coulomb. Okay, and then we use this formula to relate the voltage difference and the separation of the two plates, which is E equals to delta U or delta V over the separation D. Okay, so 800 Newton per coulomb equals to the difference in voltage over the separation D, which is 0.1 meter. Okay, so here actually I encourage you guys to convert all the units into standard SI units at the beginning. So like 10 centimeters, we convert it to 0.1 meter, 5 microcoulomb converted to coulomb, and 2 gram converted to 0.002 kilogram, and then you won't be troubled by the units conversion in the middle. Okay. So this means that delta V will be 80 volts. It will be 80 volts. Okay. Yeah, and here let me remind you something that we usually have 2 units for electric field. First is Newton per coulomb, and another is volts per meter. And these 2 units are actually equivalent. They are completely the same to each other. It depends on like which field you're in and what kind of problems that you're dealing with. Okay. So the first answer is 80 volts. 80 volts voltage difference. Okay. So now the plates are moved closer together to a separation distance of 4 centimeters. Sorry, my Discord is, I don't know who's telling me, but yeah, let me close that. Okay. Now the plates are moved closer together to a separation distance of 4 centimeters. The battery remains connected. If the charge in part A above is released from rest at point B, here at point B, very near the negative plate, how fast will it be traveling at point A, very near the positive plate in the new configuration? Show your reasoning. Okay, so the battery is not changed, which means we still have 80 volts here. Okay, and the charge at the beginning is at rest at the plate B. Okay, so at the beginning we have no kinetic energy. Okay, but at position B, then we have some sort of velocity, because here the electrical potential energy will be converted into the kinetic energy. So basically we want to find the change, the net change in the potential energy, delta U. Okay, or I should write delta P, potential energy, PE. Okay, and this PE is determined by this formula, delta U, delta V times Q. Okay, because we know that it's a negative charge. So, and this is a positive plate, and this is negative plate. And the force acting on this charge is to the left. So the ball wants to go to the left, and we let it to go to left. So therefore, the ball does go to where it wants, and therefore, it's the potential energy will be decreasing. Okay. So the potential energy will be 80 times 5 times 10 to the negative 3 coulomb, and it's 0.4 joules. Okay, and this portion of energy is converted completely to the kinetic energy, and we can write 1/2 times mass times velocity square, 2 gram 0.002 times v square equals 2.4, and you can solve that. V should be lowercase v, a lowercase v. Okay, a lowercase v. And lowercase v will be 20 meters per second. Okay, and this will be the answer. Okay, yeah. And then the last question: find the electric field between the plates in new configuration. So here, I think this question is very straightforward. So E basically is defined as the voltage difference delta V over separation D. Okay, so yeah, it's just 80 volts over 0.04. over 0.04 meter, and this will be 2000 volts per meter. Okay, so actually the units of the electric field indicate, well, it's not indicate, but you can remind yourself these formulas by looking at the units. Okay, if the units is this, then it makes you to think that you probably should use delta V, the voltage difference, over separation D. If the problem use this units, then probably that you're going to use this formula, the force over Q. Okay. Yeah. So this is the working sheet for today, and yeah, good luck on your exam tomorrow. It's the first exam, and I don't know how it will go, but yeah, work hard, and I think you'll get what you deserve. Yeah. Okay, see you guys. See you later.